All right, so today we're going to talk a little bit about solving rational equations. So we know rational numbers, we're looking at numbers that can be written as a fraction. So rational functions, same thing. There's these functions where a lot of times we have a fraction bar, and so solving rational equations, well, what's the difference between a rational function and a rational equation? A rational function is something where you're plugging in inputs and getting out outputs, whereas a rational equation, you're setting two things equal to each other. So in this case, we have x plus 1 over x minus 4 is equal to 0. And in order to solve this rational equation, we're trying to find for what x values is this true. Okay, so you've probably done problems similar to this in Algebra 2 or Algebra 1. The way we're going to think about this is let's just treat all of these as fractions, right? This is x over 1. You could call this 0 over 1. So one way to look at it is let's get the lowest common denominator. In this case, it's going to be your x minus 4. And you're going to multiply everything else to make sure that it has the common denominator of x minus 4. So we're going to multiply x by x minus 4 over x minus 4. Right? We're multiplying this first term by x minus 4 over x minus 4. Why are we allowed to do that? Well, x minus 4 over x minus 4 simplifies to just 1. So you're not actually changing the term. Right? If we wanted to, we could go through and cancel both of those out. And we would be left with just x, which is what we started with. Okay, and then we still have the plus 1 over x minus 4. And that's going to be equal to 0 times x minus 4 is just still 0. So we can rewrite this as 0 over x minus 4. If you want to include this up here, 0 times x minus 4, you can definitely do that. Just know when you distribute, multiplying 0 times anything, you're getting out 0. So in this case, and I'm going to write all of these in parentheses just because I wrote that first one in parentheses. Now in this case, whenever we're looking at fractions, say we had a problem and we're looking at, I'm just going to do this in green because it's kind of a side note. If we're doing 1/4 plus x over 4 equals 3 over 4. In this case, how do you solve for x? You kind of ignore the denominators. Right? You could say, well, I'm going to multiply everything by x minus 4 so that x minus 4, the denominator just kind of cancels out. We can forget about the denominator for a little bit while we're solving these rational equations. We'll need to bring it back at the end, and we'll talk about that a little bit later on in this video. But if everything has the same denominator, we can just equate the numerators, and by that, I mean just forget about the denominator. Say x times x minus 4 plus 1 equals 0 times x minus 4. I'm just going to write a 0. So this is x squared minus 4x plus 1 is equal to 0. How do we solve for x now? It's a quadratic because we have x squared. So we can try and factor this. Well, what multiplies to negative 1 and adds to, what multiplies to 1 and adds to negative 4? No integers that we know of. So we're going to use the quadratic formula. X equals 4 plus or minus square root of b squared, so negative 4 squared is 16, minus 4ac, so 4 times 1 times 1 is 4, all over 2a, which is 1, so 2. And this is going to be square root of 16 minus 4 is the square root of 12, which we can rewrite as the square root of 4 times the square root of 3, or 2 root 3. So this is 4 plus or minus 2 root 3 over 2. And simplifying that, make sure you divide everything by 2. We get x equals 2 plus or minus 2 over 2 is 1. So just square root of 3. All right, x equals 2 plus or minus square root of 3. So now we take a look and say, well, would this work in the original equation? The only reason it wouldn't work in the original equation is if it would make a denominator 0. Remember, we cannot divide by 0. That's undefined. Well, if we plug back into plus or minus square root of 3. That's not going to make the denominator 0 anyways, so this is our answer. Okay, we don't have any extraneous solutions in this case. Let's talk about extraneous solutions. Actually, I'm just going to clear this whole thing. Let's do another example where we do have an extraneous solution, just so we can see what exactly does that mean. Extraneous solution is where when we finish solving for x and we try to plug it back into that original equation, it's not going to work. And a lot of times, especially with rational functions, it's because it's going to make our original equation, it's going to make one of the terms undefined. So in this next equation, we have 2x over x minus 1 plus 1 over x minus 3 equals 2 over x squared minus 4x plus 3. An important thing to note here is that x squared minus 4x plus 3 factors to x minus 1 times x minus 3. Oh, well, look at what are my denominators? X minus 1, x minus 3, and then x minus 1 times x minus 3. We want every term to have the same common denominator. So I'm going to multiply my first term by x minus 3 over x minus 3. X minus 3 over x minus 1 times x minus 3. Multiplying that second term, what is that missing? It's missing an x minus 1, so plus 1 times x minus 1 over x minus 1, x minus 3 is equal to 2 over, this one we don't have to change at all because its denominator already was x minus 1 times x minus 3. All right, great. Now we have the common denominators. Let's just equate the numerators. 2x times x minus 3 plus, this is just x minus 1 equals 2. It's going to be 2x squared minus 6x plus x minus 1 equals 2. And again, we have some x squared, some x to the first, so we're going to want to get everything on one side. If we can factor, that's what we'll do. So 2x squared minus 5x minus 3 equals 0. Okay, factor by grouping. What multiplies to negative 6, right? 2 times negative 3 is negative 6. So what multiplies to negative 6 and adds to negative 5? That's going to be negative 6 and 1. 2x squared minus 6x plus x minus 3 equals 0. Now factor out of that, factor out of that. So we can factor out of 2x and we're left with x minus 3. And we can factor out of 1 and we're left with x minus 3. That's equal to 0. So this is 2x plus 1 times x minus 3 is equal to 0. And finally solving, we can say x equals negative 1/2 and 3. All right, so we get our first look at an extraneous solution now. If we were to plug back in negative 1/2, none of our denominators would be equal to 0. However, if we plug in 3, right, if I take that and I plug it back into the original, I'm going to get 6 over 2 plus 1 over 0. So this would make a denominator in that original equation equal to 0, which makes this an extraneous solution. Okay, and I want you to identify that as an extraneous solution. So what's our answer? Let's just circle that. A little bit of a mess, but we got it in there. Okay, so that's our solution to this. And we labeled that solution as extraneous. The only real solution is negative 1/2. All right, so looking here, this method of thinking was let's get a common denominator and then just equate the numerators. Well, that's pretty much the same thing as, say, what if we just multiplied every single term by the common denominator, just to start off right off the bat. If I were to multiply this first term right here by x minus 1 times x minus 3, if I were to do that, well, the x minus 1 is just going to cancel with the denominator. So I'm left with 2x times x minus 3. My second term, the x minus 3 in the numerator will cancel with the x minus 3 in the denominator. So I'm left with just plus x minus 1. And here, the x minus 1 in the numerator would cancel with the x minus 1 in the denominator. X minus 3 in the numerator cancels with the the x minus 3 cancels with the x minus 3. X minus 1 cancels with the x minus 1. So you're just left with 2, which is the same exact thing as what we have down here. So there's really two different ways of thinking about it. The first is to say, well, let's get a common denominator, and then we can just equate the numerators. And the second way of thinking about it is just multiply everything by the common denominator right off the bat. Okay, either way, you're going to get the right answer, so it's your choice on how you want to think about that. All right, so this is solving rational equations, and hopefully that helps you out with the homework or preparing for the quiz, whenever that may be.